Hi, everyone. My name is Marwan. I am a software engineer at the New York Times, and the title of my talk is Handling Go Errors. A little bit of background about myself is that I've been a backend engineer for about 2 years, doing primarily Go. And before that, I was a front-end engineer doing a lot of JavaScript and React at a Brooklyn startup. And before that, I learned modern web development using Ruby on Rails, and I have no computer science background. And the reason I'm saying this is because I'd like to make an assumption. And this assumption has become a little bit less true over time because Go has become very popular. What is this assumption? Go is not your first programming language. A lot of the people that I've met, and also that I know, have come to Go from a different programming language. And why is that important? Why is the fact that Go was not your first programming language ever, why does that matter at all? The reason is that if you're coming from a different programming language, you tend to focus on the syntax. You already know a lot of computer science concepts, you already know programming, you've done it before, so you tend to assume that the concepts are similar, you just want to learn how to do something. For example, a syntactical question could be, how do I parse a JSON string in Go? If you know how to do that in JavaScript, you already know what that means, you just want to learn how to do it in Go. But imagine if you're a beginner to programming in general. Does that question even make sense? Someone who's a beginner to programming might not even know what a string is, let alone JSON. And so the conceptual question you should be asking yourself is, what is data serialization? And that's a better question because that kind of looks at the concept of things before you look at how to do it syntactically in Go. And even more importantly, how does Go approach data serialization? Another question would be, how do I import a library in Go? So for example, if you use any other language, you probably know how to import other code. But that might not make sense if you're new to programming. The better question to ask yourself is, what are dependencies? Maybe more even broadly, what is code reuse? And finally, same thing with errors. A lot of times, if you come from a different language, you say, how do I catch an error in Go? Because you already catch a lot of errors in many different languages. The question you should be asking yourself is, what is error handling? What does it mean for something to go wrong? And how does Go define error handling? And this way, you get to kind of learn the concept a little bit more. So the conclusion is that I encourage everyone who is a beginner to a new language, regardless of whether it's Go or something else, is that you should probably learn like a beginner so that you can focus on the concepts because there could be subtle differences between conceptual things in programming. And so let's look at the concepts of errors in Go. We've already looked at a little bit of that, so it's going to be quite helpful from earlier today, is that the first concept in a proverb is that errors are values. What that means is that to the Go compiler and the type checker, an error is just as important or just as unimportant as a string or an integer or anything else. Meaning that if you have a variable declaration that is an error and a variable declaration that is a string, Go doesn't care about the difference. So the pro is you get to define the importance of an error. Because it's just a variable declaration, because it's just an interface implementation, you get to say, what kind of information does this error have, and what kind of information doesn't? On the flip side, you get to define the importance of the error, and that could be really bad. If you're feeling really good on one day, you could write a really good error, but if you're feeling lazy on one day, you might even completely ignore that error. Much of the discussion and the proposals about in the Go community that Russ touched upon today is the fact that what can the Go language itself do to encourage you to maybe do a better job or like to kind of remind you to make sure to handle your errors correctly. So the way I think about it is that if I want to narrow the scope a little bit, to think about maybe, okay, errors are values, but values can be anything. Can I define an error in a narrower scope that might not apply to all programming, but maybe most of use cases? The way I like to think about errors is that they're kind of like I/O. Errors are usually read from somewhere, and they're usually written to somewhere. But where they're read from and where they're written to really varies. It's still broad, and context matters. So the things you should be thinking about is your program a CLI tool? Is your program a library that other people are going to use? Or is your program a long-running system where errors should not terminate the program? Who is consuming your program? Is it another program? Is it people? And how? And so all these questions really should make you think about errors and then handle them differently. There shouldn't be one true way to handle all errors in all of programming ever. So let's look at a couple of examples. Through a simple program, every time I learn a new language, I'd like to make a virtual sandwich. And let's look at how we can handle errors in Go from the ground up. And then we're also going to go and look into more complex systems. The sandwich we're going to make is the one at the bottom left. It has 3 ingredients. Let's imagine the ingredients come from different markets. The first one is from Trader Joe's. The avocados come from Whole Foods. And finally, the bread comes from ShopRite, or Shoppers. I forgot. So let's imagine that we have all of these libraries and all these shoppers in different libraries. And each import path will give you the ingredient that you want. So for example, you can call buy avocados, buy eggs, and buy bread. And for the sake of brevity, let's imagine they all return the same type signature. They all return an ingredient, but they could possibly go wrong. The way we would write this function, if we wanted to write a getIngredients function so that we can make our sandwich, is that we're just going to call out each library. So Whole Foods.buy avocados, Trader Joe's.buy eggs, Shoppers.buy bread, and then we put all the ingredients in a slice, no pun intended, and then we'll return them to the caller. The question is, how do I handle errors in Go? That's the fundamental question, right? And because they're just values, this is how Go defines the error interface, which we all know by now. What this means, this is the minimal building block. This is the least that you can do to satisfy the error interface. But it certainly shouldn't mean the most. But for now, since we're beginners, we'll accept it. So we'll do the famous if error not nil, just return it up the caller. If you think about errors as I/O, you can think of it as a buffered I/O. You're just passing it back. And let's try to run the, before we run the program, let's look at the main function. So the getIngredients, if it goes wrong, it means we really have a missing ingredient and we don't want the sandwich unless it has all the ingredients, so we can safely panic here because we want to exit out of the program. And panicking is okay in this particular instance. Now if we run the program and actually something did go wrong, imagine we get this error, ingredient not available. The question you can ask yourself is, well, which ingredient? Imagine if you go to a supermarket and you say, well, can I have some eggs? And the person who's going to answer you, they assume you just asked for something, and they assume that you know what you just asked for. They don't have to be robotic and say eggs are not available. They could just say, well, we don't have it, right? So there is a question and an answer. But in this instance, we forgot the question. We only have the answer. Maybe we have stack traces. If you come from a different programming language, stack traces tend to be the go-to thing to see where something went wrong, to get that first question. However, our stack trace does not show the getIngredients function. That's because only panics show stack traces. If you remember, errors are just values. They shouldn't contain stack traces. They're just values. And therefore, we only panicked in the main function, and we have no stack trace. So the second proverb is that don't just check errors, handle them gracefully, meaning add a little bit more information to the error itself, make sure you know the context and you don't lose the question you asked. So this comes to decorating errors in Go, which is a very common convention. How do we decorate errors in Go? How do we add more context to the error itself? In Go, you can do font.error format, and in 1.13, you can add the %w so that you preserve the original error. But the idea is the same. You add your unique message, and then you extend the actual error. And this way, when something goes wrong, you can look at your unique message, and that's the where, and then you see the answer, which is the why. For the last decade, package errors has also been pretty popular. As Russ showed today, there's a lot of different packages, but let's assume this is the one we're going to use, where we can call errors.wrap. And it works very similarly. You pass the error, you pass a unique message, and that's how you get errors. Now, what we have to do is we need to put unique messages. So on every error statement, or error block, you'll see that we're calling errors.wrap, but each string is very unique. Could not buy avocados is not mentioned twice, is only mentioned once. So if we run the program again, we're finally going to get our full answer. Could not buy eggs because the ingredient is not available. So this is the where, or the what, and the why. So that's great. And more importantly, we kind of don't care about stack traces anymore. We kind of got everything we need, and we could just kind of ignore the stack trace. So the third thing I thought when I was learning the new concept is that stack traces tend to be for disasters. A lot of Go programs is that you print a stack trace if you really don't know what happened. And stack traces in general, they're hard to read. They're pretty long and ugly. They're hard to parse, so they're kind of difficult to query for unless there are special programs that parse stack traces for particular programs. And at best, they say where an error happened and not why. Where did the error happen, but they don't tell you exactly why. So stack trace is also not really efficient. And what if we want to act on an error? What if we want to say, look, okay, we know why something went wrong, but we don't want our program to completely fail. Maybe if the eggs are not available at Trader Joe's, we're okay to pay a little bit more and buy them at Whole Foods. And so errors, just like any other interface, they're comparable and nullable. So we can compare if an error is not, if it's the type of that is Trader Joe's error not available, we're just going to get our boiled eggs from, say, Whole Foods. And so the takeaways is that we can handle errors gracefully. We don't have to panic everywhere. We can trace the error back to the code, and we can act upon an error. The question you want to ask yourself, is this enough? And for a lot of simpler programs, certainly. You can, especially if you're writing a CLI, you're writing a simple tool, this is usually more than enough. But what about complex system? What if you're writing a program that has to be maintained for a while? And the answer, I believe, is no. And here are further things you can do to your Go programs. You can categorize errors by severity. So just because an error happened doesn't mean it's an error that you should pay attention to. The severity could be an info level. So if you think about structured logging, this is the severity I'm thinking about. The structure or the log level could be info, debug, warning, or error. So this is, you can categorize all your errors by that severity, and you can embed it in the error itself. You can categorize errors by type. So think about maybe an unexpected error or a user error, like user is not found, the password is incorrect, a bad request, an authorization request. You can add application-specific data. It shouldn't stop at just the typical things. If you're writing a program that is a food delivery app, you should probably include things like the restaurant ID, the zip code, or where things are. Most importantly, in my opinion, the things that I've learned is that you can query all the above. Just because you created the right error doesn't mean that the goal here is done. The goal is that you can later on inspect errors and query and ask really specific questions and be able to get those answers back, given the data you put. So part of it is the data you input, and then the other part is the reading and the querying that you do later. So fast forward 1 year, when I was learning all these Go concepts, I started working at the New York Times, and my first team was the account API. If you're a New York Times subscriber, which I hope you are, you come and you want to change your password, you want to change your email, maybe you want to suspend your home delivery paper or whatever it is that you want to do that has to do with your account, you go to your profile. The profile is a UI written in JavaScript and React, and it talks to one API. Now, like a typical microservice architecture company, we have one gateway that the UI talks to, but this gateway talks to a lot of underlying APIs because each one is separated by concern. So I have a paper delivery API that will tell you something like, when is your paper supposed to get delivered today? Is it at your doorstep? Is it missing? Is the weather really bad and your paper going to be, arriving late? We have a typical login and register API so that you can sign in or sign up. And you have a subscriptions API. We have different products, so the subscription API tells you if you're a subscriber or not. And maybe emails API. Let's say you forgot your password, we want to send you an email. And the accounts API talks to all of them under the hood. If you think about this for a second, this is really not that different from making a sandwich. It's a more complex system, but at the end of the day, it's the same. Basically, you have the sandwich, which talks to that get ingredients function, which talks to a bunch of different libraries under the hood. So it's really not that different. The only difference is it's a long-running system, and so instead of panicking, we don't want to halt the program, we want to log and monitor. So the getUser function, you can think of it as the equivalent of the getIngredients function. It takes a user ID, and we call 3 different APIs. The login service to validate that the user ID is correct, the subscription service to say what kind of subscription you have, and then maybe the delivery service to say what time are you supposed to get your paper today. And then we return those kind of just like the ingredients, the subscription, the delivery time, and a possible error, because something can always go wrong. And now, instead of panicking, And instead of having it in the main function, we have a particular handler, which is a typical HTTP handler. And this way, we just say, if something is wrong, I just want to log it. And now we want to monitor our logging. Because it's not a program that's written once and run once, it's basically going to happen over time. Errors could come from a lot of different places. And this is the way we monitor it. We use Google Cloud, and we look at our monitors to see what's wrong. However, everything is the same level. If you focus on these errors, one error could be account is not active. Another error could be user entered the wrong password. And something like user abandoned request, and more and more and more. What I want to do is that I want to separate errors that I'm expecting from errors that I'm not expecting. I want to inspect if my system is working properly. I want to inspect what's going on in my logs. And everything is kind of like one big log file. And that's really hard to filter through. So I set out some refactor goals. The things that I want to do is that I'd like to filter unexpected errors. Anything that could be wrong that I haven't accounted for, I just want one click of a button, and I want to see all of this. I want to group by error types. Sometimes something like if there's bad weather in New York, and I want to say, well, show me all the errors that are happening. They're expected. We're expecting that sometimes the delivery paper is not being delivered, or maybe it's late, but I want to see them. So I want to categorize by error types. And I want to be able to answer specific questions. If your product manager came and told you, how come there was something wrong on September 30th with this particular zip code, with these particular subscribers, you want to be able to go through the logs and basically write a query and find all of that and be able to get the answer quickly. So I started looking for inspirations, and if there is one advice I give you today is that you should probably read these articles. They're awesome. The first one is called Error Handling in Upspin by Andrew Durand and Rob Pike, and the second one is called Failure is Your Domain, which is actually inspired by the first one. And they both give you a similar idea about how you should structure your errors. The idea is that you have your domain, and your domain is your business logic. And that business logic usually talks to a lot of third-party services. It could be a database client, it could be maybe 2 internal services, and a third-party library. And they all return their own special errors. And each error, what you're supposed to do is that you probably want to convert specific library errors to your own domain errors, so that your domain, think about them like your handlers, could talk to errors in the same way. An error that is not found, it doesn't have to say if it's service A not found, or if it's service B not found, or if it's a SQL not found. To give you a little bit of an example, imagine you have a database interface where you can say, you can get by ID, and it returns a database record and a potential error. But let's say your program is complex and you use multiple different implementations. You have a SQL implementation, you have a file system implementation, and a MongoDB implementation. Your handlers, what they have to struggle with is that whenever they call db.get, they don't know what implementation you're using. So they have to check against every error not found. And each one is a different type. For example, SQL has an error no rows if something is not found. OS has OS is not exist function, which returns a Boolean. And then MongoDB, the MongoDB client, has a Mongo error no documents. So imagine doing this everywhere all over your code. And what the article suggests is that you should probably abstract that away, and so that your handler could just say, is this a not found error, instead of like worrying about what the implementation is. So how do we do that? Think about maybe creating your own package for your errors within your code base. Whether this is shared with other libraries or not, at the end of the day, it's up to you. The whole idea is that you probably need to do what makes sense for you. And the second thing we want to do is we want to probably create an error type. As we learned earlier, it could just be a string, or it could just be an integer. It could be any type. But a struct allows you to add more information over time, and it allows for you to not break anything if you just want to add extra information. What do we put in the error struct? The first thing you might want to put is an operation. An operation is that unique message that we were talking about. An operation is basically where in your code something happened. And the second part you might want to add is a kind, which is the category of the error. Is this a not found error? Is this an unexpected error? Is this an authorization error? And the last part, you want to embed the original error so that users could retrieve it again. You don't want to lose that contextual information. That's the why. That's the wrapped error. But perhaps most importantly, these are basics. What you might want to add is application-specific data, and that's where things get interesting. That's where you put all your metadata inside your error struct. So how do we construct an error type? Just because we defined it, we want to learn how we construct it. In the Ben Johnson article, he suggests that you could just basically instantiate it like any other struct. If error is not nil, just return the error and then like define all the fields that you want to define. In the upspin case, there is a helper method called e, and e takes basically a variadic argument of anything. And then we basically iterate through all of these arguments and check the type, and based on the type, we actually fill the error struct. And if the type is not recognized, this is an error within our code base and we can panic right away. This way means if you do an if error not nil, you can just call errors.E and pass all the variables that you want, and it doesn't have to be like 4 or 5 lines. You can pass the kind and the embedded error and the operation, and even your application-specific data. So let's look at an operation. What is an operation? It's a unique string describing a method or a function. Multiple operations can construct a friendly stack. So let's take a look at how that's written. Instead of writing the unique message on every return statement, you can define the operation once at the top of your function. So for example, in the getUser, we have something like account.getUser. So it might even describe the package where something happened. We inverse the uniqueness of the message. It's not about the message itself, or the wrapping message is not what the function we're calling is. It's the function that's being called from. But if we trust that whoever we're calling is also doing the same thing, like for example, the validation function has also its own operation, then we're not going to lose that context. We're going to see like kind of a stack trace of what operation called what operation if you're wrapping all the way back to the caller. And then if the error is not null, you can see that we just call errors.E and we wrap everything. Now, in the errors package, we might want to have a helper function. And this is where it gets to the idea that you can really do whatever you want. You don't have to write this function, but for me, it kind of made sense. If I give it an error struct, I want to get a list of all the operations. And the way to do it is that you start with a top-level operation, and you do a typecast. If the internal error is also wrapped, it's also the same type, then I can basically call myself again in a recursive way and pass the underlying error. And then I keep populating the slice until I have a full stack of wrapped errors. So the errors.Ops returns something like that, which is just a slice. And it's also easily marshaled to JSON. So what you get is, you can think of it as a JSON array of strings. And this array of strings literally is your stack trace. But your stack trace looks something like this now, something that you've written yourself. And a traditional stack trace looks like that. And in my opinion, it's a little bit uglier. Again, if I want to look at the previous one, this is really easy to read, and it also has only your domain logic. And that's also a better part. If you think about the error stack trace, it has a lot of stuff that's happening internally within Go, like even the panic itself, which is, you can see on the second line, it's runtime/panic. We don't care about that. We just want to see where something went wrong in our domain and not the entire stack trace. So the benefits of an errors.Op is you have a custom stack trace of your code only. It's a lot easier to read, but what's easier is that you can easily parse it and query it. You don't need to have any special program to query over an array of JSON strings. You can write a little script that just parse it and then query anything you want. And you can also, because of this type of querying, you could look at the impact it has in your application. So to give you a bit of an example of what you can do with this kind of slice, is that you could query your stack, and this is kind of like pseudocode in a way. You can imagine if you have some sort of a database of all your logs, you can do something like select star from all of my logs, where the operations include this field, which is login.validate. What you return is you return a list of logs. So imagine if your validation function had a bug, and your product manager or engineering manager says, well, what's the impact? Why? It's a function in the middle of a big code base. Who is calling this function? What handlers? Not just in general, not just in the code base, but let's say in the last 30 days, were there any requests that reached that code? Just because it's being called from 10 places doesn't mean there were 10 errors. Maybe only one user kind of wanted to validate who they are. And so you can do this kind of complex query parsing. One final thought on the operation field is that you can make your stack even simpler by removing helper functions from the stack itself. And if you look at this helper function, it takes an operation as an argument, and it returns a potential error. And this way, when it's wrapping something, it's not wrapping the operation of the function itself, it's wrapping the operation of whoever got passed it this operation. In this way, you can actually get reduced stack traces. So if you have a helper function that's being used in a million places, it's always going to show up on the stack, and you could just easily remove it. So you're in control of your own stack, and that's kind of the point. Now let's look at the error kind. The error kind groups all errors into smaller categories. They can be predefined codes, like HTTP, which is just integers. And they could be error codes like gRPC, or you can define your own. So let's say we pick HTTP. We can say a kind not found is an HTTP status not found, which equals 404. And a kind unauthorized is whatever, and an expected is whatever. So this idea is that when you want to talk with your errors API, you can say, is this a kind not found? Basically, even though we can say, is this error kind 404, it's probably a little bit easier to say if this is something that is not found, and if we want to later change what these codes are under the hood, we don't have to change our code everywhere. So we're abstracting the actual underlying implementation. We're just kind of talking as if it's an interface. To extract an error kind, we basically unwrap the error to see if it's of the type. If you're given an error that has never been wrapped and it's never been defined within our domain, that's probably an unexpected type. And if the kind is not 0, because we know it's an integer under the hood, this is the implementation, we can return it. Otherwise, we can pass the underlying kind, meaning like we can recursively go until the first error that was wrapped that had a particular kind that the code base asked for. One thing you can think about is that if your kind is an HTTP status, then you can propagate the error all the way back to the client. And now you're setting that error category across the wire. So just by defining an error struct, you're actually also defining your response error. So the getUser handler has something like this. Instead of just saying this is a 400 or this is a 500, what we can do is we can call http.error, which takes a string, and we don't have to say exactly when it went wrong because this is a client. Maybe we don't want to expose internal system error information, but we can pass the kind. You can see the third argument is called errors.kind, and that returns an integer. And that's exactly the status code we return all the way back to the client, whether it's a UI or anybody else. But if you look at the logging, it still logs logger.error. And that's where we come to the severity. And that's the additional information you can even add to your struct. If you're using a logger like Logris, which is used by a lot of open source tools, you can embed the level right away. You can just say, well, this error is pretty expected. This is the operation, this is the kind, but here's also the log level. And so now, the getUser, let's imagine that any validation error is something we're expecting, meaning like the user did not pass the right cookie or they did not pass the right ID. And this is always something we expect because users maybe put their wrong password or something. And so you can see in our errors.E function at the top, we pass loggers.info level directly into the errors constructor. And that's all we care about. We don't care about what people do with it. We're just saying, hey, this error is expected. It's info. But the handler now could do something a little bit more complex. It could check the error itself, it could unmarshal it, and it could just look at what the level is and log based on that. You probably want something like a helper, which is something I usually call a system error, something that the system understands. So you call logger.systemError, which you define yourself, and then it will basically look at the severity. But more than the severity, it can add its own information to the log. So let's look at an example of that. The system error, like any other function that we saw so far, it can basically typecast the error into the type. But if the typecast is not correct, well, that's an error we don't know what it is, so we know the level is logger.error, because we don't know what it is. Before we actually get to figure out the level of the error, we can add more fields, because we know an error has a lot of helpful information. We already defined our struct. It has the operations, it has the kind, and even more application-specific data. So you can automatically add that to all of your log entry before you even log anything. And then finally, we could do a switch statement on the errors level. So imagine we have another helper, which is called errors.level. It basically does a recursive call to find the first level it can find. And this way, we can say if it's a warning level, we can call entry.warn. If it's info, we call entry.info. And if there's nothing, maybe we could default to error again. This way, we have the operation. We know where something went wrong. We have the error. We have the entire information of an error. Maybe if you're, again, whatever type of app you have, if you're a music app, you'll have like the song ID and the album ID right in the error itself, right in the log, actually, not just the error. And then you also have the right level. So let's think about like some potential application-specific data. Again, if you're a music app, you can add the artist and the song. If you're a delivery app, you can add the zip code wherever you're delivering to. If you're an email application, you can add maybe where this is coming from and where it's going to. And if you're maybe a food delivery app, you could say like, what time did the order happen? What's the restaurant ID? At the New York Times, I've added a lot of information when it comes to something like, where did a delivery go wrong? What kind of user was it? What's the user ID? Where is the zip code? All of these things we can just add and then query on our own time. So these are some of the questions you can answer. You can say, show me all the delivery errors in zip code 22434. Or show me all the food delivery errors by seafood restaurants. Maybe you include the restaurant category in your errors. Show me all the errors that happened while trying to stream the latest Beyonce album. You can just basically ask these questions without doing anything. So the takeaways are that the error interface is intentionally simple, and that I encourage everyone to design an error package that makes sense to your application and no one else, by adding your own stack, by adding your own information to it, and then you don't have to basically copy and paste it everywhere because it only makes sense for your application. And the quote that I use from all these proverb talks by Rob Pike is that a big part of all programming for real is how you handle errors. So I hope you're always thinking about it. Thank you.